Hi everybody, it's Mrs. Dinkelman, and we're in Unit 8 talking about arc length. This is a pretty short section. We just really have to memorize the formula. I'm going to talk a little bit about how we get that formula. We can see that arc length formula is just the integral from a to b, the square root of 1 plus dy dx squared, and then dx. Again, we could switch the variables if needed on those. This formula hopefully looks a little bit like Pythagorean theorem, and honestly, that's what we use to calculate or to figure out what the formula is. If we just think about little tiny pieces of line segments added together, that would get us close to finding the area of, or not the area, the length of the curve. And if we could get those to be infinitesimally small and add up an infinite amount of them, then we would get the exact length of the curve. So hopefully that sounds again like an integral. We've talked about that a lot so far, about getting things to be have an infinite amount of things to add together, which is exactly what the integral is. So I've attempted here to kind of put what the proof is. So if we're trying to look up here at the picture, so S1, if we were doing Pythagorean theorem, this is how we would calculate it. And then kind of knowing calculus, changing those deltas to dx's and dy's, and knowing that it's really easy for us to figure out what dy dx is and manipulating here. So that's why we would divide by dx squared. So we can see this dy dx here, and then that turns to a 1. That's still squared, so we square root both sides. And then we can figure out just by moving the dx over what that is. So we would integrate there to figure out what's going on with the formula. So this is really just a matter of knowing the formula and knowing how to plug the pieces in. So for example, 1 here, we just figure out what dy dx is. So that's negative 2x. And then we plug it in our formula. So arc length 0 to 3, square root of 1 plus. And you can either simplify this or you can just write it as that thing squared and then dx. And then we're either going to just calculate that by hand or it's going to be something we do on the calculator. You can see here that this is looking a lot like a trig sub. And so hopefully we won't have to do that. We'll just get our calculator for those. So again, just a matter of knowing that formula and plugging pieces in and getting used to it.